In this video, we're going to be talking about how to find perimeter and area of three different shapes: triangles, parallelograms, and rhombi. The reason why we're doing all three shapes is because they're very much related. Let's try and think about that as we're moving through the notes here. First thing is to find perimeter and area of a triangle. We got three types of triangles. The area will be the same no matter what type of triangle it is. It's always half of the base times the height. And the reason why is because a triangle is always half of a rectangular square. So it doesn't matter if you have a right triangle, acute triangle, or a obtuse triangle, or whether it's isosceles or scalene, this will always give you the area. The tricky part about this formula is finding the height of these two types of triangles. For a right triangle, the height will just be one of the legs, and it doesn't matter which is which. When you do base times height, it doesn't matter what order you multiply in. So for right triangles, there's nothing tricky about it. The acute and obtuse triangles are going to be tricky in that you're going to have to sometimes draw a height, also known as the altitude of the triangle, and you're going to make sure that it's perpendicular to the base. So you end up creating a right triangle. There's actually two of them. Doesn't matter which one you use. And you're going to use your right triangle methods to help you solve for some unknown measure that will help you finish off this formula. So we'll do that in our examples. To find perimeter, you could keep it simple and just add up the three sides of the triangle, or you could try one of these fancier formulas depending on what type of triangle you have. Let's get to the examples. In this example on the left, we're given an equilateral triangle, told that all sides are measuring 6. So to find the perimeter, we just add up the three sides or multiply 6 by 3 and get a perimeter of 18. To find the area, though, we need to know the height of this triangle. Since it's an equilateral triangle, we could just say that any of the sides is the base. So we'll use the bottom just to keep it easy. We'll draw in our altitude, and altitude always comes from a vertex and is perpendicular to a base or the opposite side. And it's always going to bisect that base. So if I bisect a measurement of 6, I created two smaller measurements of 3 on either side. So to find the height, we could just think about the Pythagorean theorem. We have two sides. This is 3. This is unknown. And our hypotenuse is 6. So we could say the hypotenuse squared minus the leg squared, and then square root that is the height. We could put it in radical form, 3 times the square root of 3, or decimal form, about 5.2. We could also take a shortcut, though. Use our special right triangle properties for a 30, 60, 90 right triangle. Because this is an because this is an equilateral triangle, all the angles are the same measurement. If I divide 180 total degrees inside a triangle into 3 equal parts, each angle must be measuring 60 degrees. So this angle is 60. The altitude is going to bisect that vertex angle, cut 60 in half. That's our 30. So across from the 30 is our short leg. If that was a measurement of 3, then the long leg is just that value times the square root of 3. So the height must be 3 times the square root of 3, which is the same thing we get by using the Pythagorean theorem. So now that we have our height and our base, we can multiply those two values together. 6 times 3 times the square root of 3, and then cut it in half. And we get 9 times the square root of 3, or approximately 15.6. In the right example, we're going to do the same thing in that we're going to draw our altitude or the height of the triangle. Make sure it's perpendicular to the base here. And it's going to bisect that length of 8 into 4 and 4. So we have a right triangle. We know that one of the sides is 4. We're missing the other leg, and the hypotenuse is 6. So again, we could use Pythagorean theorem to find that height. And in doing so, we could use radical form, 2 times the square root of 5, or about 4.5. Now that we have our height and our base, we can multiply them together and divide by 2 and get either 8 times the square root of 5 or its decimal approximation, about 17.9. We have enough information to find the perimeter. These two sides are equal, so 6 plus 6 plus 8 gives us the distance around the triangle, which is 20. So there's triangles. We're going to need that information when we talk about parallelograms. Here's a generic parallelogram. Opposite sides are going to be equal. Doesn't matter which side you call the base. So to make it simple, we'll just always use the bottom as the base. The height is the trickier part in a parallelogram. We can't use this slanted side. That would be a slant height, and that's not the height that we want to use to find the area. We need the height that's perpendicular to the base. So sometimes you're going to have to draw in that height and find that length using some right triangle methods there. The area of a parallelogram is base times height. Same thing as a rectangle. The perimeter is also the same as a rectangle. Since we have opposite congruent sides, we can use that rectangle perimeter formula and add up the sum of our dimensions and double it. Or you could keep it simple and just add up all four sides. That's up to you. Let's jump into some examples here. The example on the left. We're given a side length of 8 and a side length of 10. So we're going to call 10 our base and draw a height that is perpendicular to it. Because we're given the 60-degree angle and we just created a right triangle, that must mean that this angle over here is 30 degrees. We can use our special 30, 60, 90 properties. Across from the 30 is the short leg, which is always half the hypotenuse of the triangle. So this little length must be 4. The long leg is always the short leg times the square root of 3. So this must be 4 times the square root of 3. So now we have our height and we have our base of 10. We can multiply those two things together to get the area and say it's 40 times the square root of 3, or its decimal approximation 69.3. To find the perimeter, we got all the sides we need. We could add up all four sides or use our fancier perimeter formula, add up the dimensions and double it, and we get a perimeter of 36. The example on the right. One more time, we're given a length here of 5 and a partial length of 7 here. So if we draw our right triangle, let's try and figure out some dimensions here. We're given the height of 4. So how can we figure out some of these measurements? Well, over here is 5 because opposite sides are congruent. So now we have a triangle where we know two sides, and it's in a ratio of blank 4, 5. And if you know your special right triangles, one of them is a 3, 4, 5, the ratio of the side lengths. So you could assume that the missing measurement there is 3. If you forgot that, you could always use Pythagorean theorem because we know 2 out of the 3 sides of this right triangle. So we could say x squared plus 4 squared equals 5 squared, or jump to our side length or leg formula, which is the hypotenuse squared minus the other leg squared and then square root it. Either way, you get 3. So we know that our total base length is now 3 plus 7 or 10. So we could do our area base times height, 10 times 4, which is 40. And we could add up all four sides to get our perimeter, or add up our dimensions and double it. Either way, we get a perimeter of 30. So there's parallelograms. Try and create right triangles to find the height if it's not given to you. The last shape is a rhombus. So I'm going to save this one for the next video. Do it in 2 parts.